Hi friends, as mentioned in my previous video, I am going to give clear picture about what is partitioning and existing in SQL Server 2015 onwards. So this example will work from 2015. So there are steps for creating partitioning. If you see here, we have to first create the file groups. Creating file groups is an optional. So we can use the default file groups as a primary if required, or we can create a separate file groups for each partitions. It all depends on us. And next, create a partition function. So here we have to specify the partitions uh, for the table, for the object I mean. After that we have create a schema. In this schema we have to specify what is the partition file group and partition function, and the next step is a create clustered index on a table based on the partition schema. So these four steps are mandatory if you wanted to create a partitions. So here I'm explaining in clear diagram here. So I will go. First, when we are planning to start a partition, first determine object should be partition required. So this is not something like we have to partition on each and every table, but it's not like that. We have to, there is a requirement, otherwise there is no use of partitioning at all. So normally we will go partitions where the object is contain millions of records, and it's not so system is not processing, and we need to archive on the table on particular time and we have to patch the data on specific date. So in that scenario only you have to go for partition. So it's not mandatory to go for each and every scenario to partition an existing table or creating table. So we have to determine first, and suppose if you find that it's not required to partition, then go for normal creation object, normal procedure creating object. So if you decide the partition, and next step is to determine the partition key and number of partitions. So we have on the table we have to determine what is the partition key. That's mandatory, and a number of partitions are required. So normally partition key is going to be date field. So from the date field we have to decide how many number of partitions are required. So if you decide that, then document the reasons for that. So why we are partitioning those many numbers and why are taking that column, and create one or more file groups. So as I mentioned, this is optional. We can use the default primary file groups also. Then we will proceed for create partition function with the partitions, and next step is create partition schema, and the other step is create object on partition schema. So once these steps are done, we have to reference that schema to existing table or create table, and create aligned indexes. So once partition schema defined on the table, we have to be create align indexes on the table, and the final step is create other partitions objects with the same function for alignments, benefits, and same schema for storage alignment. So if you wanted to, there is a primary key, reference key scenarios, better to use same partition schema alignments for those objects also, to make a move from it's easy to move one partition to another partitions, or we can truncate those partitions easily. So these are the steps for partition and tables. So I'll show you some examples about create file groups. So if you wanted to create a file groups on any particular database, first we alter the database with the file group name here. So here this is the file group, and that file group again you have to use that file group with with altering uh, that is same database and assign some space to that file group. This is the syntax if you wanted to go for file group. So after that, as I mentioned, second step is create a partition function for range partition. So once you create the partition, you have to create a range of partitions. We have left and right. So if you create the left partitions for that date, 2000 October 1st, so the left partition is going to be like that. First partition for all data less than or equal to 2000 October 1st. But second partition is all data about 2000 October 1st greater than. So this is for left. The right is the opposite of that. First partition is less than of 2010 of first, and second partition is greater than or equal to 2000. So this is the example if you are going for left and right partitions. It all depends on us which partition is required. So that is the second step. Third step is, as I mentioned, we have to create partition schema with that function. This is how we are going to create a schema. Create partition schema name as partition. This is the partition function name or the date range which we have created above. So sorry, the function not here. So it could be below somewhere. So once partition schema defined with the partition function and partitions. The same thing for suppose if you don't want file groups for each partition like that, then we can all set to one primary group. So this is how we can create a partition schema, and this is the where we can retrieve the partitions details. And this example you can see on Google. If you try that, then here we are going to add that that existing schema to existing table. So if you see that I am trying to alter tables and add the constraints and primary key clusters and order date and order ID with and I'm referencing to 2 years date range. This is my schema. So here if you see that I am taking the column, I mean partition column as a order date. That's where I am mentioning to my partition, and I'm also assigned a clusters index for the order date along with order ID. So order ID is my primary key here. So I'm also adding the order date to that primary ID, and I'm referencing to my scheme here. So if you wanted to add same thing, if you wanted any other column to as a primary key, you can also add here. That's the example here. And this is for splitting and merging the existing partitions. Suppose if we wanted to add a new partitions for existing schema, this is the syntax. How to alter partitions function and the name of the function, and split range, you have to specify the range here. And So if you wanted to suppose in case if you already partitioned completed or it's moved that partitions and you are no longer in use, it is no longer in use, so you can, in that case you can merge that partitions to and make it a one partition. So this is the syntax: alter partition function, name of the function, merge and range of. So it is going to merge those functions, that range. This is the overall picture about partitions in SQL Server 2000, SQL Server in SQL Server. So as I mentioned, if you wanted to create a function for partitions, this is the syntax: create partition function and as range left or right for values of this one. So this is the overall picture about the partition in SQL Server. And now I will go for give you some example about uh, partitions in SQL Server in detail. Now I have created two tables. One is address and archive table, address archive. So if you see that I have some data inside here, and I wanted to partitions in this table and partition column order underscore date uh, and weeks wise. So my requirement is I want to partition my table and my address table and if, uh, in weeks wise. Like my requirement is I wanted to archive my address table every 2 weeks, and I wanted to truncate my data from my archive table on every 4 weeks. So this is my requirement. So right now there is no partitions here. If you see that this is so, before that I will show you one view here. I have created a view. So this example you can find in Microsoft website. It is nothing but to show you how many partitions are there on this particular database. So this is shortcut to view stored procedure, the details and any other. So sp underscore help text by giving that name, so it will give uh, the code inside of that. So I can take copy from here. Since I already created, I am commenting this, and if you execute this, is nothing but it's going to retrieve existing partitions from the database. So right now there is nothing. So on the whole, it's going to create return boundary value, rows and partition number, table name, function name, and schema. So we have to join these many tables. So tables, indexes, these are all system tables, partitions, partition schema, function, and range values. So it's going to retrieve the means partition details from this table as from the table wise. So for this I have created a view, and to minimize the data. So this is the same view. I'm here. So if you execute this, at present there is no partitions. So let me create a partitions. As I mentioned, this is my exam. This is my requirement. Archive every 2 weeks from live, delete every 4 weeks from the archive. So first that we have to create a schema. First that we have to create, since I am using a default file group, so I am not going to create any explicit file groups here. First let me create a function and schema, and and that schema I need to reference to these tables, and after that create a aligned index for that. So these 4 steps I will perform now manually. So I also created a automate this process. So I will show you that SP step by step. First let me create a manual way. I have prepared the data so to make it a video short. So these are my partitions. So if you see that these partitions are created for every 2 weeks. For example, the partition 3324. So this is the current partitions. So I have divided like so I wanted to archive every 2 weeks data, and I wanted to remove my archive table every 4 weeks. So I have created my partitions past as well as future. So that we can keep the data means so we can keep, it's easy for us to maintain if we create it like this. So I created a previous 2 weeks, total 4 weeks partitions, and future total 3 weeks. So for example, I have for this there is a partition for current, and I have created less than 2 weeks for one partition, and for this less than 2 weeks for one other partitions. The future partitions I have created plus 2 weeks on partition, and again plus 2 weeks for these partitions. So total partitions I created 6. So same way you can also create the partitions based on your requirement. Suppose if you wanted to every month, you can create a partitions 2 months before, 2 months before, 2 months after. Like that, every 2 weeks, every 3 weeks, 3 months means 6 months before, 6 months after, like that. So you just created. Don't create a single partitions or 2 partitions. Create as much partitions as you have as it is. Otherwise, sometimes it's difficult to maintain. So be try to create as much as partitions. So means if you create more partition, there is no harm at all, because it contains no rows. But if you have short partitions, it could be problem in case of you wanted to move from live table to archive. So I created a depends on my requirement. These are my partitions. Function name is pf partition function, and schema I have created, and I used a primary file group to all my partitions. So this is syntax, and I aligned my tables with primary clusters index. My partition column is order date, as I mentioned before, and I also created archive table with the same partitions. So I referenced here my partition schema. So this is for archiving of from live table to archive table. So this is syntax. Here you have to specify the partition number between these two tables. Those partitions must be matched. You cannot move partition 1 to partition 2 here, because the range is different. So if you wanted to move from live to archive, you always be maintain the same range otherwise you'll get the error. And after you archive, if you wanted to purge this, the move data after some time, then this is the syntax: truncate table, my archive table with partition number. So be planned well and make it accuracy while truncating, because after you truncate you are going to lose the data permanently. So be cautious about that. And since so here if you see that this is my partition 1, partition 2, partition 3, partition 4, 5, 6. So since I already moved my partition 1 to archive and also removed from the purge table, so this partition is no longer required because it's already done. So you can match that partition. So if you match, after you match, then the latest lowest partition is going to be this one. So after that, then so we have to create a new partition for future purpose. So that's where we have to create a new partitions, and you have to create a new partitions, and create new partitions from the syntax: alter partition function with the partition name, and split. You have to specify the range. This is the partitions in for manual. If you want to do manual way, this is the these are the steps you have to maintain. So at present I don't have any partitions here. You see that my partitions are empty. So this, since that is the view, so we can directly access that partitions. Yeah. So because we can see that how partitions are happening. Short this. I also minimize this. So let's start creating the steps. Let's execute the first partition. So let's create the new function. I hope before that, let's make sure that drop existing partitions, otherwise you will get error. So let me create my function. So step 1 succeeded, and then I need, so if you try to execute here, it won't show anything, because this function it's not yet referenced anyway. So let's create a schema, that is the step 2, with the same function. So it has completed successfully. Now let's add that schema to my table. So this is my table. I am taking alter table orders and add constraints, constraint name, and primary key clusters, and order ID and order date. This is my partition column, and on partition scheme with order date. So I am specifying here partition scheme on my order date. So here see that this is my date time column. So I'm also creating a partition partition schema on this date. So these both should be same, data type should be same, otherwise you are going to get error. So please bear in mind. Normally partitions will create on date time columns, so the data type should be same. So I'm creating partitions my order table based on this structure. Let's try that. So it's saying it could not be refreshed. Let's refresh now. So it seems there is no because I already dropped that previously. Let me create those tables now. So I have already selected me. So tables are created. So I'm also so if we refresh here. So let's see that what is the table right now. So if you see that my order table having order ID, user ID, order amount, address, and status ID, and active, and order date. So same syntax for archive. One more thing, the both columns should be exactly same and with data types, otherwise the partitions will not happen. So here also add the date and let insert some data into that. It's going to see that insert 2 times, 3 or 4, 6 times. So I'm inserting some demand data. So if you see that my order table should have some rows. So this is my data. So I'm going to create partitions on this table right now. So let's go to our example. So let's try this. Previously it got failed because of there's no table inserted. So my partitions got created on this table. Try with the archive also. So it got 6. So now if you observe it, I have successfully created my partitions and address archive. Let's see that how it is happened. So my successfully created a partition on my both tables. So if you see that if you go here, so these are my partitions I have created. If you see that the same way it has created. So it is showing rows also. Just now I inserted some rows. And if we observe here, this data is going to be like that. The partitions are going to be like that. So since I have created a right partition, range of right here, so my data is going to be like that. So it's going to be first partition or less. So as I explained in my previous example here, if you are right, so it's going to be the data range going to be like that. So less than or equal to partition, greater than or equal to partition. So it is going to be less than or equal this one. So in my partition 1 is data is going to be less than or equal. So let's try for one live. So we have one stored procedure. So this stored procedure will give how these partitions are divided. So if you see that my address table partition for this range is greater than or equal to min value, it can be anything. So since it can be last record greater than or equal last record to from below February 4th. So the date. So this partition is what are. So this partition will accept boundary value will accept this data less than or equal February 2024 12 a.m. So if you see that the boundary value of this one, this is going to be like that, greater than or equal February 2024 February 18, less than February 8. It's not less than or equal less than February. So this how my partitions get divided. You can see that. So you always keep maintain one empty partitions always. Otherwise, if you restrict like this, so in case if you want, if you while automation, if something goes wrong, data gets inserted, so it's going to be issue because there it doesn't find any partition. So you always maintain one empty partitions. So that data will going to sit here. This is my last partition. So this how I partitioned my data. So it's time for archive now. So let's imagine your archive date has come and there is a job runs on archive date, and it's time to move the archive boundary values of 2024 to 20, I mean February 4th, 2024 to archive table, move to archive table of here. To do that, this is a syntax. So it's saying that archive of means transfer of address table partition 1 to R. So if you run this statement, so it got successfully. If you see it again, so if we see that this rows get 0, and if we see that my archive table get added those rows, means I have successfully moved boundary value of this data, values of this data to archive table. Now it's time to uh, let's imagine this data is archived more than 4 weeks and I wanted to truncate that data. So let's try to truncate. So I'm saying truncate table with the partition 1. So let's try this. So if you truncate, this row will get 0 successfully. Let's try this, see how it is happening. We see that it has been truncated. So I have successfully truncated after 4 weeks. Now it's trying to match up this boundary value because it's no longer in use. So this is the syntax for match. After match, this boundary value is going to be lowest one. So it got matched. Let's see that. See that 18 is going to be lowest. So my already done partition has been moved. Now it is time to create a new partitions. So there is one more syntax got missed here. So let me wait. So this is the main to split that. First we have to specify the my next partition is which file group it's going to be. So I'm saying use my primary. So if you execute this, I'm going to create a new partition with this state. So some conversion fail. Let's try fix that. So I have created one. I have created this new partition range. You can see that. So get added 28. Like this, you can add new partitions after you matched the already used partitions. So this is the and this how we will create a partitions, and we can automate this process also. It's a very simple, and we have to be some have to use some while loops and if conditions, uh, and we can make a partitions. I mean automate of this process. So based on that, and I will show you a procedure I already created. So this is the procedure I have created. So if you want, I can share this one, and quickly I will go glance, and so it's nothing like you have to give. First you have to means you have to means first you have to set the run date. So since this uh, it's a date wise, first you have to set the run date, actual run date. So from that run date you have to go particular partitions from query, and you can uh, so here I am just give overall means idea how we can uh, go for automation. So suppose if user pass the run date and take that run date and detect 2 weeks, because we need to go previous uh, boundary value, so that we can retrieve that partition number. So that's first you have to deduct 2 weeks and get the date, and since we have the means view already I have created, this is my view. this is my view. So here we will have the complete details about what is boundary value, partition number, and all. So what I did was first I get the details from that view and insert into temporary table, because I can't use these conditions on every time. So to make a short, I just created a temporary table at the beginning with this condition, so that I can use for remaining uh, remaining places. So first I'm checking whether is there any means already functions already created or not. If not, I'm creating those initial partitions. So I'm just taking since these are my custom logic, so you can also build your own logic. So first you have to loop lowest and highest weeks and create a partition range. So if you loop this one, you are going to get these values, and after that after it completes, then create a partition function with that partition range. It's nothing like since before I am creating manual, here I am creating dynamically to that partition range, and I'm creating schema. I'm altering my table with primary key and as well as archive table. So this is the creating of partitions. So after it done partitions, since I'm having a run date after deducting 2 weeks, so I'm retrieving my historical data and rows. And if I see that if it has the rows, like if you see that let's take that I'm running this partition. So I'm going back these partitions because I wanted to move archive which is less than or equal to weeks data. So I'm going back here, and from this date I'm giving less than of this date. So I'm going to retrieve this I will retrieve this information, and I'm checking if it has the data and partition number. Since if we don't have rows, if we don't have data on the partitions, no need of move, right? So I'm just checking here and moving. This is my initial run. So it is not going to run every time. It's going to run for the first time. I will create partitions and move that initial history data. So if it comes the next time, then my else part will execute. So this is for archiving. So the same logic will occur here. I'm just checking is less than or equal to the date, so by deducting 2 weeks, and I'm checking the historical data and all. So before that, suppose if and the same thing. So if it has rows and partition number greater than, then I am switching the rows here by dynamically getting that partition number. And the suppose in case in case while doing that, if any partitions are failed, some issue are occurred. Suppose let's take that I am archiving this data in case of failures are occurred. So archive doesn't happen, but when it's come to next time, so it's going to check this week, this 2 weeks, this weeks also. If it finds any rows in this, it will automatically move. So that is logic here. And while loop, and the while loop I am checking if it has any previous rows has not moved already. So those data I am just moving from putting into the while loop. So I will share this information. Same way purge also. So there's a purge every 4 weeks. So I am deducting my purge data minus 4 weeks. So from that date onwards, I'm just doing my logic. So this is just simple. The main thing here is this view, this data, this view. So this view will give us the complete detail partitioning. in our logic, we based on this data, based on our logic, we can move and we can patch. So that is the logic we have to build. It's very simple. If you need anything, please let me know. I will share this complete code so that you will get idea. This means the parameters is not so meaningful, so you can change if required. Uh, I hope I explained in detail about table partitioning um, step by step. I think you got some idea. And if you need any explanation and some information, please let me know. Please comment and I will update. I will come back, reply back to you with the details. Thank you guys. Please keep watch my videos. Thank you.